Hello. So I covered the science of flat Earth and how people learned that the Earth was round, and theories going back to ancient times to how it became important for actual navigation and so on. So that was some of the things that we have known for thousands of years, and there are a lot more things. The history of science is very old. So what is science really? It's just a way of thinking that's very precise given the way our brains, our minds are made. So, you know, it's something that a child does, which is basically to observe, to watch the world, make theories about the world, and verify that those theories are correct, usually by doing experiments. So that's the basic concept of science. And in society, we have many different kind of pulls on us, and science is one of the things that human societies do. So we have seen how we have geometry with us for thousands of years. We have had other kinds of sciences. Calendars are an example of ancient science, and they were very important because calendars are important for farmers to know when to plant seeds, when to harvest, etc. And they also have been known for many thousands of years, the science of calendars that we just take for granted now. And well, we observe many things on Earth, like, for calendars we observe seasons, but we also observe stars. Turns out, you can see that there are stars on a clear night, and people in ancient times had a lot more time than us, and their skies were very clear, and a lot of them liked to study the stars. And over a lot of time, a lot of observations emerged. So people slowly learned that there were stars that were fixed in our sky, but there were some bodies that were not fixed, and they called them planets. And they learned about them, a lot about them. And even before the telescope, they knew a lot about them. They had charts, they had numbers, they had all kinds of observations, very interesting observations. So besides stars and planets, there were these wandering bodies that would sometimes show up, comets, and these were often spectacular, and people studied them. And a very interesting piece of information came about, which was that when a comet goes by Jupiter, the planet Jupiter pulls it in. And this was an interesting behavior, and a name was given to this behavior. It was called gravitation, and the pull of the planet Jupiter, that was called gravitation. Now, as I mentioned, in Europe, interest in science became very strong because of this debate over whether the scholars really knew what they're talking about when they said the Earth was round. So because of this interest, people started learning other things about what scholars said. And among those, there was a geometrician. He wasn't called a scientist or a physicist back then, because geometry was the closest they had to modern science. So there was a geometrician named Isaac Newton. And he had a very interesting idea. And the story goes that he saw an apple fall, and apparently from that, he made the connection that an apple was just like a comet, a falling thing. And just like Jupiter could pull comets, same way, the Earth was pulling the apple. So what he did was he extended the concept of gravitation to everything, and he called it the theory of universal gravitation. So it wasn't just Jupiter pulling things, everything was pulling everything else. So this was an interesting concept, and he had a lot of data to verify it, not on Earth as such, because the measuring wasn't that precise, but he had a lot of data from the study of stars and planets, and he could check his theory. He could do experimental verification. Turns out some of the data was actually wrong, and but he didn't just say data is wrong. He spent a lot of time working with the wrong data until finally he was very convinced. And then he came out with his theory of universal gravitation. And with that, and with some laws of motion, he was able to explain a lot. So that's Isaac Newton's theory of universal gravitation. And it was very big, because it didn't just work in the skies, it also worked on Earth itself. You could figure out how fast things would fall, what was the falling behavior. If you drop something, at first it falls slowly, as time goes by, it falls faster. So all those things could be explained. And that's how we have the theory of universal gravitation. Now, this theory explains how the world works, and for quite a while, this was very satisfactory. But of course, in science, anybody can challenge any theory. That's, ideally. Of course, there's a lot of politics and stuff, but people used to be more idealistic about science, and they did believe that anybody could challenge. Even Isaac Newton's theory of universal gravitation, which had proved so successful. And somebody did challenge it. About 100 years ago, a patent clerk came up with a challenge to Newton's theory of universal gravitation. His name was Albert Einstein, as some of you have figured out by now. And Einstein offered a different explanation than Newton's. Now, in Newton's theory, there is mass and there is attraction, just like Jupiter's attraction, but everything has a force of attraction, and you can use those forces to calculate their behavior. Now, we have talked about Euclidean and non-Euclidean geometries. They talk about the flat Earth. So Einstein based his challenge to Newton's theory of gravitation on geometry. Actually, I should explain that before he did that, he had also done something else. People were finding out that everything we could calculate was relative to something else. When you use Newton's laws to calculate how fast something falls, you're not taking into account that Earth is moving and spinning. So it's only relative to where you're standing. Even if you take into account Earth's rotation and orbit, you don't know what Sun is doing, and you don't know if there is any absolute at all. And this was disconcerting to the scientists of the time. So Albert Einstein proposed that the speed of light was an absolute, and he called that his special theory of relativity. In this theory, everything can go hang, speed of light is totally absolute. And even time flow changes, as long as we maintain the speed of light. So that was an absolute he gave to the people, and it was a very interesting concept. And then he followed it up with a challenge to Newton. And he basically said that the geometry of the universe causes things to fall. So that's Einstein's theory of gravitation. And interestingly, Newton came after centuries, Einstein came some centuries after that, but lately, every decade, we have people who are coming up with new theories of gravitation. It's almost like a cottage industry. So, which all that can be very interesting, but the thing is, these theories become very complicated, and people who do advanced physics in these theories, they need to understand the basics. So I hope I have explained theories of gravitation well now, but for people who are doing research in these fields, advanced research, who have their own theories, or people who are seriously curious about the science of these theories, I have written a book called From Light to Eternity, a New Science. I'm sorry, the full name is A New Science, and the subtitle is From Light to Eternity by Mukesh Prasad. And I do suggest that people who are seriously interested in these theories of science, including light, physics especially, this is all mostly physics, they should read that book. And with that plug, which I think is a very important book for anybody interested seriously in science, I'd like to conclude this lecture now. Thank you.